This problem asks us to evaluate double integral of e to the power of x squared with bounds of x and y, x being between 5y and 5, and y between 0 and 1. Now to start, we see that the integral of e to the power of x squared dx is actually impossible to find. We can't integrate it. So to solve this problem, we're going to switch the order of integration.
And in order to do that, we have to visualize it a bit. So I've created this chart. So if we look back here, the original integral bounds are 1 and 0 for dy, and 5 and 5y for dx. So to illustrate that, that means that 1 and 0, this would be the y bounds, and 5 and 5y. So 5y, all that's basically saying is that like it would be similar to an equation, and this would be the equation of that bound. It would be 5y is equal to x. So essentially, in order to switch the integrals here, we need to switch the bounds as well. So we would have our new dy would be 0 here, as we're starting from 0. And we would want to solve this equation here in terms of, and get it in terms of x. So we would get x over 5. And similarly, the dx integral bounds would be 0 and 5. So eventually we have this expression over here, and let's try to solve that.
All right, now to start solving this integral, the first thing we want to do is find the antiderivative of e to the x squared with respect to y. And since we are integrating with respect to y, we can treat e to the x squared as a constant. So our integral comes out to be y e to the x squared, and we want that from the interval x over 5 to 0. So all of that's going to be within our outer integral of 5 to 0. And that's dx. So the next step would be to plug in these values, x over 5 and 0, into y e to the x squared. So we'll do that. No, that's wrong. You want to plug those values in for y. So we have x over 5 e to the x squared minus 0 e to the x squared. And this cancels out because it turns into 0. So our new integral, which is now only going to be a single integral, is going to be the integral from 5 to 0, x over 5 e to the x squared dx.
Now we have the final integral. We're going to use u substitution in order to find the value of it. U is going to equal x squared, and du is going to equal 2x dx. Then we are going to take out the constant 1/5 and multiply it by 1/2 from the u substitution, and we get the function of e to the u. Once we take the antiderivative of that, we get 1/10 e to the u on the bounds 0 to 5. When we plug back in the x values, we get 1/10 e to the x squared, which gives us e to the 25th over 10 minus 1 over 10. Finally, we simplify that to e to the 25th minus 1 over 10.